Today, I want you to imagine this. You're crossing the street, and a self-driving car rolls toward the crosswalk. You slow down a bit. The car slows down too. You look at each other. Well, you look at its sensors, and you're both kind of negotiating who moves first. Moments like this happen all the time when humans and autonomous systems share space. But here's the real question. How can a robot stay safe when the world reacts to its own behavior? That's what today's research is all about. So the study we're exploring today tackles a surprisingly tricky problem. Many autonomous systems, cars, robots, drones, try to predict what people or other robots will do next. But predicting human behavior is already hard. And predicting behavior that changes because of you is even harder. Think of it like trying to guess someone's next move in a dance, while you're still figuring out your own choreography. Every move you take influences the other dancer, and every move they make influences you. Traditionally, engineers used a method called conformal prediction. It creates a little safety bubble around predictions. If the system says a pedestrian is likely to walk forward, that bubble accounts for uncertainty. Maybe they walk a bit faster, maybe a bit slower. But here's the catch. Those bubbles only work when the environment behaves the same way it did in the past. And in interactive settings, it doesn't. Change the robot's behavior, and humans change their behavior too. This makes old safety bounds unreliable. So what did the researchers do about it? They introduced a clever idea, a way to continuously adjust the robot's uncertainty bubble every time it updates its strategy. Instead of assuming the world stays the same, the system asks, if I change my behavior a little, how much might the world change back? It's almost like the robot becomes more socially aware. Every time it collects new data, it recalibrates its understanding of the people around it. Every time it updates its decisions, it adjusts its safety bubble to stay, well, safe. And importantly, it does this while keeping strong mathematical guarantees that no matter how the world reacts, the robot's predictions remain reliable. It's like a dance choreography where one dancer can safely adapt even when the partner improvises. To test their idea, the researchers set up a simple scenario, a car and a pedestrian interacting. What they found was encouraging. The system learned over time, refined its predictions, and stayed consistently safe, even as both sides reacted to each other. This opens the door to safer streets, safer warehouses, safer everything. Any place where autonomous systems and people move together. So the next time you see a self-driving car hesitating at a crosswalk, you might wonder, could systems like this help it make better, safer decisions in real time? Thanks for listening to the R&D Lab. Visit engisphere.com to explore the engineering concepts. If you enjoyed today's episode, hit follow and share it with someone who loves tech that meets real life. See you next time, where curiosity meets engineering.